Let's now have the second problem, and the second problem would like us to find all of the higher derivatives of this function, right? So basically, we're just going to get the derivative of the derivative of the derivative of this function until our answer would be equal to 0. All right, so in order to do that, first, we're going to solve for y prime. And solving for y prime, this is in the form of u raised to n. All right, so this is in the form of u raised to n, and the derivative with respect to x of u raised to n is equal to n u raised to n minus 1 du over dx. So y prime would now be equal to 4 multiplied by 1 minus 2x raised to 3 multiplied by the derivative with respect to x of 1 minus 2x. Alright, so n u n minus 1 du over dx. So this is now equal to 4 1 minus 2x raised to 3 multiplied by the derivative of this one, which is equal to negative 2. The derivative of 1 is 0, the derivative of negative 2x is negative 2. Therefore, y prime is now equal to negative 8 multiplied by 1 minus 2x raised to 3. Alright, so that's the first derivative. Now, for the second derivative, this is now equal to the derivative of the first derivative. So, this would be negative 8. This is still in the form of u raised to n. So, if it is still in the form of u raised to n, therefore, the derivative of this one would now be 3 multiplied by 1 minus 2x raised to 2 multiplied by the derivative with respect to x of 1 minus 2x. So simplifying this is now equal to negative 8 multiplied by, or that is negative 24, I should say, multiplied by 1 minus 2x raised to 2 times the derivative of 1 minus 2x, and the derivative of 1 minus 2x is negative 2. Alright, so this is now equal to negative, positive 48 multiplied by 1 minus 2x raised to 2. Alright, because negative 24 times negative 2 is positive 48. This is now the second derivative. For the third derivative, this is now equal to 48 multiplied by the derivative of this one. So the derivative of 1 minus 2x raised to 2 is 2 multiplied by 1 minus 2x raised to 2, raised to 1, because 2 minus 1 is equal to 1, times the derivative, right? So the derivative of 1 minus 2x is negative 2. Okay, so this is now equal to 48 times 2, so that is equal to 96, and 96 times negative 2, that will give us negative 192. Alright, so 48 times 2 is 96, and 96 times negative 2 is negative 192 multiplied by 1 minus 2x. Okay? Now, solving for the fourth derivative, this is now equal to negative 192 multiplied by the derivative of this one. Alright, so that's negative 2. And negative 192, so the fourth derivative, negative 192 multiplied by negative 2 is equal to 300, positive 384. Is that right? Alright, so that's 384. This is now the fourth derivative of this function. And solving for the fifth derivative, the derivative of a constant is now equal to 0. Alright, so this ends the solution for this problem. For the third example, we are given here y equals x plus 2 all over x squared minus 1, and we are required to determine or solve for the second derivative of this function, right? So now, solving for the first derivative, before we do that, let us just recall the formula that we are going to use. Now, this is a quotient, so if that is a quotient, the derivative with respect to x of a quotient, u over v, given that u and v are functions of x, this is equal to v du over dx minus u dv over dx all over v squared. Right? So if we're going to use this formula in solving for y prime or dy over dx is now equal to v, so that would now be x squared minus 1 multiplied by the derivative with respect to x of x plus 2 minus x plus 2 multiplied by the derivative with respect to x of x squared minus 1 all over, right? So that is x squared minus 1 quantity raised to the second power. Okay? So we have v, which is x squared minus 1, du, the derivative of x plus 2, and then x plus 2, derivative of v over x, all over v squared. Okay, so this is now equal to x squared minus 1 multiplied by the derivative of x plus 2, so that's equal to 1, minus x plus 2 multiplied by the derivative of x squared minus 1, so the derivative of x squared is 2x, and the derivative of negative 1 is equal to 0, all over x squared minus 1 raised to the second power. So if we're going to simplify this one, we have x squared minus 1 minus x times 2x, so that will give us 2x squared, and then 2 times 2x will give us positive 4x, right? All over x squared minus 1 quantity raised to the second power. So simplifying this is now equal to x squared minus 2x squared will give us negative x squared, and then negative 1, alright, so negative 1 minus 4x. Or if we're going to interchange that one, this is negative 4x and this is negative 1. Right? All over x squared minus 1 quantity raised to the second power. This is now the first derivative of the function x plus 2 over x squared minus 1. So solving for the second derivative of y, and since the resulting first derivative is also a quotient, then we are still going to use this formula. Alright, so the second derivative is now equal to v, which is x squared minus 1 raised to 2 multiplied by the derivative with respect to x of x squared minus 4x minus 1 minus negative x squared, alright, so that must be negative x squared, negative 4x minus 1 multiplied by the derivative with respect to x of x squared minus 1 raised to the second power, all over, right? So we have x squared minus 1 raised to 2 raised to the second power, that will give us raised to the fourth power, right? So this is now equal to x squared minus 1 raised to the second power multiplied by the derivative of x squared, which is negative 2x, the derivative of negative 4x is negative 4, and the derivative of negative 1 is 0, minus negative x squared minus 4x minus 1 multiplied by the derivative of x squared minus 1 raised to the second power, that will give us 2 times x squared minus 1 raised to 2 minus 1, so that is basically equal to 1, multiplied by the derivative of x squared minus 1, which is 2x, all over x squared minus 1 raised to the fourth power. Alright, now we are done with the differentiation part. And to get to the final answer, we need to simplify the resulting expression. Right? So the technique in simplification here is not to expand the numerator, but to factor out or to bring out common factors. Right? And if we're going to inspect, the common factor in these two terms is x squared minus 1. And if we're going to factor out negative 2 in this expression, or positive 2, that will give us negative x minus 2. Alright? So The common factors are 2, because we have 2 here, and we also have 2 in here, and x squared minus 1, because we have x squared minus 1 here, and we have x squared minus 1 in here, right? So if we're going to bring out 2 and x squared minus 1 in this expression, or in this term, our remainder would be x squared minus 1 multiplied by negative x minus 2. And if we're going to bring out 2 and x squared minus 1 in this term, the remainder would be negative x squared minus 4x minus 1 multiplied by 2x, right? All over x squared minus 1 raised to the 4th power. So simplifying further, we have 2 multiplied by x squared minus 1. So if we're going to multiply this term, or these two products, we have negative x raised to the 3rd power minus 2x squared plus x plus 2. And if we're going to multiply or distribute 2x in this group, we have negative 2x cubed minus 8x squared, right? So that is minus 8x squared minus 2x, right? So if we're going to perform the operation, the resulting expression would now be negative x cubed minus negative 2x cubed, that is positive x cubed, negative 2x squared minus negative 8x squared, that will give us positive 6x squared, and then x minus negative 2x, so that will give us positive 3x, and then lastly we have positive 2, all over x squared minus 1 raised to the 4th power. Now, since x squared minus 1 and x squared minus 1 in the denominator is a common factor, so we can cancel out x squared minus 1 here, and the denominator would result to x squared minus 1 raised to the 3rd power. Right? So the final answer for the second derivative of y is now equal to 2 multiplied by x cubed plus 6x squared plus 3x plus 2 all over x squared minus 1 raised to the 3rd power. Right? So this would now be our final answer.